This video is about options for time division multiplexing. The first possibility is a fixed arbitration strategy where systems have predefined time intervals that they can use to send data. This method requires clock synchronization so that all systems have the same view about begin and end of these time intervals. In some terminology, only this method is called time division multiplexing. However, since also the two other methods in this video provide different times to different users, they are classified as time division multiplexing here as well. In the variable arbitration strategy, systems can in principle send at any time. However, there is a control mechanism which makes sure that only one system uses the medium at a time. This can be implemented by a coordination unit or by a decentral algorithm. Finally, there is the random access mechanism where systems can also send at arbitrary times. However, there is no or only limited control concerning the access to the medium, so that collisions can occur. Now we start to take a look at the methods in detail. In the fixed arbitration strategy, the time is divided into time intervals, which are called time slots. In the network, there is an assignment of users to these time slots, which is the same for a longer period of time. On the bottom of the slide, we see a simple example. The users A, B, and C can use time slots after one another, and then again time slots for A, B, and C are available. However, as we can see, time slots can stay unused if a participant has nothing to send. In the example, B completely uses the available time and has maybe more to send, while the others use their time slots only partially. If we discuss advantages and disadvantages, we see that this method leads to a low overhead in the data units. It does not have to be mentioned who the sender of a data unit is, because this can be concluded via the time slot. In addition, the method allows guaranteeing a minimum bitrate based on the proportion that the user has related to the overall bitrate. A maximum waiting time can be guaranteed as well, because in the worst case, the time slot of the user has just passed, and then the time slots of all other users are the waiting time. However, then there is in any case again the time slot of our user. As disadvantages, we have already witnessed that transmission capacity can remain unused even if another user would benefit from it. The system can also assign bitrate capacity only according to the time slot structure. Maybe it can be a bit more flexible if you can assign several time slots to a single user. In reality, this method is used for GSM, that is, the second generation of mobile telecommunications. On one frequency, a time slot structure with 8 time slots is defined, so that 8 different users can get access to this frequency. For the variable arbitration strategy, 2 implementation options exist. One of them works in a way that there is a coordination unit. This coordination unit controls the whole network. You can call it the master and the others slaves. A slave is only allowed to send data if the master has granted it access to the medium. The master polls the slaves one after another. This means it sends data to the first slave, then gives the first slave the possibility to send its own data, then sends data to the second slave, and so on. Another possibility is via a decentralized algorithm. This algorithm is implemented in each system. The algorithm makes sure that it is clear who can use the medium at a certain moment. This requires that there is an order of the systems. On the bottom of the slide, we see an example based on the technology token bus. The token is a special data unit which indicates who has the right to send. So this method works as follows. A sends data, and once it has nothing more to send, it sends the token. The token contents is that it is now the turn of B. B can send data and later gives the right to send to C. In this example, C has nothing to send. However, C has to do something so that the schema continues. So C has to send a token data unit so that A knows that it can use the medium again. The method has the advantage that it is more flexible and avoids unused times. A system can send as much as needed and then hands over the right to send. However, there is a maximum time how long each system is allowed to send. Otherwise, a system may use the medium all the time. In this way, it is possible to guarantee minimum bitrate and maximum waiting time. The worst case is that all other systems use the maximum time that they have for their transmissions. As disadvantages, there is the overhead for the control data, that is, the tokens. In addition, it is not clear when exactly the next time interval for a system begins. The last possibility are random access strategies. Its basic idea is rather simple, because systems just try to send something if they have a data unit to be sent. Depending on the implementation, they may check whether there is already another transmission on the medium. In this case, they do not start their own transmission, but wait until the medium becomes available. On the bottom, we see an example where this method works without any problems. Since there is no coordination between the systems, it is not necessary to send control data units. Another advantage is the flexible medium use as needed, so no order of the systems has to be taken into account. However, the major disadvantage is that collisions are possible. Involved data units are lost in this case and have to be resent later. As a prerequisite, it needs to be recognized that such a collision has happened. Due to collisions, it is not possible to give a guarantee on minimum bit rates or maximum waiting time for successful data transmission, because in principle there can be collisions for any data unit that is sent. However, in advanced random access strategies, this becomes very unlikely, so that the method works quite well in reality. In the last slide, we find an overview of the use of these methods for local area networks. The fixed arbitration strategy are not in use, but I had mentioned GSM as an example for its use in mobile telecommunications. Variable arbitration strategies are in use in the way of polling schemas in HDLC and its derivatives such as the point-to-point protocol. Bluetooth uses this method and also one seldom used variant of wireless LAN. Decentral arbitration methods via tokens are used in token bus and token ring. However, these technologies are no longer available. In the context of the random access strategies, it is quite interesting that such a method has been used for wireless Aloha network at first. Then the idea has been enhanced to the CSMA-CD method, which is an algorithm for fixed networks, more precisely Ethernet. Afterwards, the CSMA-CA method has been developed for wireless LAN as an adaptation of CSMA-CD to the different conditions in wireless networks.